All right, today we're going to be looking at chapter 6.7, financial models. This is very important and very applicable to you in your daily life as far as savings and things of that go, credit card interest rates, home loans, and different things that you will use. We'll use these things. So it will give you a little bit of an insight of how some of that is computed and what's going on behind the scenes. The first formula that you want to write down is the simple interest formula. Each of the variables are identified and described here in the reading above. I is the interest rate. P is the principal, so you want to label what each thing stands for. T is the time in years, and you have to be careful as years or different time limits are given. You will have to change what you put in for T. And then R is the interest rate, and you have to express that as a decimal. That is important. So you get all these working parts, and we will compute simple interest. Okay, you can see some terms here that let you know when interest occurs: annually, semi-annually, twice a year, quarterly, monthly, daily. These will be used especially for compound interest, which they talk about here. But you can kind of see some examples and how it's used here, but we'll do that in my math lab. All right, this next computation, you can kind of go through this. It may be kind of hard to follow, but overall you need the compound interest formula here. Okay, so this is another type of interest that gives you interest on top of your interest, not just on your principal. And then P is still the same. It's the principal invested. R is still the interest rate as a decimal. Now we have this new term N. N is the number of times it's compounded per year. So if we go back to page 1, if we say annually, then N would be 1. Semi-annually, twice a year, N would be 2. Quarterly, N would be 4. Monthly, it would be 12. Daily, 365. So there are other terms, but that's just a few to help you identify N. So that will come from the reading. And then you have to multiply by T. It's really small, which again is time in years. So you have to also convert to years if needed. We'll do that also in my math lab. All right, so here are some examples of that being used in some calculation formulation. Now, there is a continuous compound formula, which they talk about this as N gets bigger, it approaches this, but this formula may be used. I don't remember if we use that, but it's important just to kind of note that and what it is. Continuous compound formula. And then effective rate of interest, we will use this. So this helps you to determine where you're going to get the bigger bang for your buck. So do take time and look at or take down these formulas, and you have an example here that kind of shows you how this effective interest rate is used. So you have 3 different banks offering you CDs. So one is giving you 2.15 and you get it monthly. One is offering you 220 quarterly, so 4 times a year, and one is giving you 212 daily. Which one would be better? So you would almost think, oh, the higher number would be better. But as you go through the computations, you'll see which one actually gives you more money over the time period that they give. So this one gives you about 2.17 when you express it, so that 215 actually gives you a little bit more. The 220 effective interest rate gives you slightly more, 2.21, and then the 212 gives you 214. So they all give you a little bit more, but the higher one in this case actually gives you the better effective rate. So that's the one you would want to go with So this says the effective highest interest rate is First International Bank. So that's the one you would want to go with. Just depending on what you're given. So finding that effective interest rate is important, and we will do that as well. Now, other than that, we don't need any other formulas, but we have present value. These are not anything extra, but it just manipulates the compound interest formula. So you don't have to take these down, but if you want, it just kind of gives it to you in formula form. But we'll do this from the compound interest and continuous interest. We'll just manipulate them. So you can get these, but you don't have to. There's not anything new. They just kind of show you how they come around with that. And I don't believe there's anything else. Yeah, and then we start problem solving. So mainly what you need is simple interest at the beginning. That's one formula. You need compound interest. Okay. We may see a continuous compound. I'm not sure. So that's 3, and then there's a 4th, effective interest rate. We'll use this as well. So jot those down, and then we'll hop on over to my math lab and solve those problems.